Hello everyone, I'm Jiayue. Welcome to my channel. In the previous videos, we've talked about the Dirac spinor, the Majorana spinor, and the Weyl spinor. So today, let's make a comparison. Let's draw a table to contrast the three spinors. So our goal today is to draw a table. And we compare Dirac spinor, Weyl spinor, and Majorana spinor. And we shall compare them in terms of these properties. First, it is a real spinor or complex spinor. Next, what is the degrees of freedom? Degrees of freedom. And then, is it has definite handedness? So this means that we shall study whether the spinors has definite handedness, whether it is left-handed or right-handed. Another thing is it is massive or massless. So this is our goal today. First, let's talk about the real complex thing. So first, for Dirac spinor, we know that it is a spinor that has 4 components. For each component, it is a complex object. So it is complex. And for Weyl spinor, we know that it is equal to some 2 component thing. And for each component, it is a complex object. So it is complex. And for Majorana spinor, we already know that in the last video, in Majorana basis, in Majorana basis, it becomes a real spinor, which means that it has 4 components, and each of them is real. But we also know that in other bases, like in Weyl basis, or some general basis, it can also be complex things, but the lower half and the upper half are related with each other, so it can be real. And for the degrees of freedom, first, let's define what is a degrees of freedom of a spinor. Our definition is that degrees of freedom equals to the dimension of our phase space over 2. What is phase space? Like in classical mechanics, you know that the position and the momentum can form a phase space. Like for a one-dimensional motion, the degree of freedom of the motion is 1, but the dimension of the phase space is formed by momentum and position, so it is 2. So our true degree of freedom is the dimension of phase space over 2. And so for the Dirac spinor, the dimension of the phase space, we will know that in the next video, the conjugate momentum is actually I psi dagger. and we have our field psi, and they are related with each other. So the real dimension of the phase space is determined by psi. How many components are there? I mean, not components. How many numbers do we need to determine this? We know that for each box, there is a complex object. So we need 2 numbers to specify each box. So the dimension of phase space is 2 times 4. So after dividing by 2, the degree of freedom is 4. And for the Weyl spinor, we know that each box has a complex number, so we have 2 boxes. So the degree of freedom of the phase space is 4. So the degree of freedom of the spinor is 2. It's half of the Dirac spinor. And for Majorana spinor, we also know that it is real, so it's 1 times 4. So the degree of freedom is 4 divided by 2, which is 2. Or you can say from this, it is complex. But the lower half and the upper half are related with each other. So it will give half of the degree of freedom of the Dirac spinor. It's 2. So this is the relationship between the upper half and the lower half. So we can build a Dirac spinor, use 2 Weyl spinor. So this question will lead us to the next term, definite handedness. We know that Weyl spinor has a definite handedness. Either it is left or right. Here, handedness I just mean chirality. Like if you have a W plus, you have a W minus, all of them has a definite handedness. But for the Dirac spinor, you actually compose the 2 things. I mean, combine the 2 things. You can write something like psi equals W plus, W minus. So this thing has no definite handedness. You cannot say the Dirac spinor is left-handed or right-handed. And for Majorana spinor, we didn't have the definite handedness. We cannot say it is left or right. You can say from here. So only the Weyl spinor has a definite handedness. You can say it is left chiral or right chiral. And for the massive thing, for Dirac spinor, we know that it has a master. I didn't show the Lagrange of the Dirac spinor, but I will talk about it in the next video. But we will know that the Dirac spinor is massive, and also the Majorana spinor is massive, but it is different from the Weyl spinor. It is actually massless. We will say in the next video the Lagrange of the Dirac spinor, and from the Lagrange we can see this, the Weyl spinor is massless. I'll keep this for the next videos. And if you also interested in this, you can read some papers related to the chirality and the helicity. It will also give us some inspiration on this massless thing. So that's today. Thank you.